Today we're going to talk about section 2.1. Functions. Starts on page 148 in your textbook. Now, if we think about it, in most everything that happens, one quantity depends upon another quantity. So some examples of that would be height, so your height depends upon how old you are, so it depends upon your age. So there's two quantities that depend upon each other. Another example would be something like if I'm going to the post office to mail a package, the cost of mailing a package that depends upon your weight of the package or the size. So again, those are two things that depend upon each other. If you're looking at something physical like a circle, if you're looking for the area of a circle, it depends upon what? It depends upon the diameter or the radius. So again, we've got two things that depend upon each other. So this relationship between two quantities is called a function. So function. Now when we think of something functioning, we think of a car functions, that means it's working, right? So a function is some sort of action taken to get a result. So function is an action taken to get a result. So for every input that we put in, okay, there's only going to be one output. So for a function is an action taken to get the result that for every input, there is only one output. So an example, going back up to the top again, talking about the cost of mailing a package. So I have this mailing, I'm trying to find out the cost, so it depends upon the weight. So if I put the package on the scales, I'm going to get one cost because the weight is not going to change if I put the package up again. So for every input, there's only one output. Now, when we've talked about domain and things like that before, we've talked about input and output there as well. So we've called the input the X value, and we call Y the output. So you've heard it said for function, for every input there's only one output. Well, you can also hear it for every X there's only one Y. So we call domain the input, and we call range the output. So give everybody a chance to catch up to this point first. So we have to know how we're going to write a function. So we're going to look at function notation. So function notation, we write f parentheses x, and it said f of x. Now we get confused sometimes because we think this means f times x. This is a name of a function, f of x. So that gives us a specific action that we're going to take. So f of x, we also can write equals y, where x is the independent variable, and y is the dependent variable. So the reason why that y is a dependent variable is that whatever x that I put in, so I can put in whatever x, it depends upon what the x that I put in was. So x is the independent variable and y is the dependent variable. So now let's try an example. F of x equals x squared plus 4. So f of x is this action's name. So f of x is some sort of rule that tells you what you have to do. So you have to square whatever input I put in and then add 4. So we have f of x, in this case we're going to write f of 3. So 3 is my input. So I'm going to input 3 in for x. So my action says to square x and add 4. So I'm going to have 3 squared plus 4. 3 squared would give us 9 plus 4 is 13. So our input would be 3, our output would be 13. So let's try another example. F of negative 2. So we're still plugging into that function, into that action. So we're squaring the negative 2 and adding the 4. So negative 2 times negative 2 gives me a positive 4, plus 4 gives me 8. Now, one of the things that you have to be really careful with on this problem is that when you put in that negative 2, make sure you put parentheses around the negative 2 if you're going to use your calculator. Now, obviously, you probably wouldn't use your calculator, but if you don't put the parentheses around, the calculator is not going to square the negative sign. And then it's going to end up getting your answer to be 0, which would be wrong. So now we're going to look at the domain of this function. So we've talked about domain in Unit 1. We said that to find the domain, we had to look at two different things, the restrictions. So we said one restriction was denominator cannot be 0, and the other one is the radicand. Now remember we said radicand was the thing that was inside the radical sign, has to be greater than or equal to 0. We can't have a negative in the radical. The square root. So in this case, here's our function. If we're looking for the domain, are there any denominators? Is there any fractions? No. Is there any square roots? No. So do we have any restrictions? No. So our domain is going to be all real numbers, negative infinity to infinity. And we're writing this in interval notation. So everybody caught up to that point? So the next thing we're going to look at is the range. So we're going to look at this function a little more detailed. When I look at this function, I see x squared. So let's try putting a few things in. So if I put in f of 0, I'm going to get 0 squared plus 4, which gives me 4, right? Okay, so what if I put in a -1? -1 squared plus 4. So this -1 is squared, so that makes that +1 plus 4 gives me 5. So what if I put in f of 1? 1 squared plus 4. 1 squared plus 4 is still going to give me 5. So you see what's happening there? That squared is going to make everything be positive. So everything is going to go higher than that 4 because the 4 is added on. So we know that the range is going to be everything greater than or equal to 4 for the range, for y. So our range is going to be brackets 4 to infinity. And that's in interval notation again. So everybody understand why that is? Now, you can also look at this kind of from our Algebra 2 prior knowledge thing, is that we know x squared is a parabola, right? And we know the plus 4 moved that parabola up 4. So that would move our y value to be up 4. So that's why another way we can look at it. So give everybody a chance to get that written down first. Okay, so we're going to do a few more examples of evaluating a function. So when it says evaluating, we're still looking at plugging numbers in. So we got f of x equals 3x squared plus x minus 5. So now we're going to find out what f of -2 is. So it looks the same thing as what we did before. We're just going to take -2 and input it for x. 3 times -2 squared plus -2 minus 5. So we simplify by putting things together. Now again, what did I tell you before about making sure you put that negative in parentheses? Because if you don't, then the calculator is going to mess you up. So we've got 3 times +4 is going to give me 12. And then I've got a -2 and a -5, which is going to give me a -7. So I get my answer to be 5. So f of -2 equals 5. So when you say it in word form, the value of the function f at -2 is 5. So this is the value of the function f. F is its name. It's not a multiplication. All right, let's try another one. F of 1/2. So we're going to have 3 times 1/2 squared plus 1/2 minus 5. So on this one, we're going to put our heads together and figure out how we're going to do those fractions. So we're going to have 3 times 1/2 times 1/2 is 1/4. So how do I make 5 into a fraction? I put it as 5 over 1 then, right? So over here we've got a 3 over 1. So now we have to decide how to put these things together. So if I've got fractions multiplied, this is going to give me 3 over 4 plus 1 over 2 minus 5 over 1. So what do we do now? We have fractions, we have to have a common denominator. So what is our common denominator going to be? 4, 2, and 1. You could use 8, but 4 can also be used because we already have this one in terms of a 4. So this would times 2 times 2. As long as we multiply the same thing in the numerator and the denominator, we're still going to have an equivalent fraction. So over here, what am I going to multiply by? 4 and a 4. So I have 3 over 4 plus 2 over 4 minus 20 over 4. So we get our final answer to be -15 over 4. 3 plus 2 minus 20. So we have f of 1/2 equals negative 15 over 4. So everybody caught up to that point? The next thing we're going to look at in this is a particular type of function. So the one we're going to look at is called a piecewise function. So we have a specific type of function that defines the action to be taken on different parts of the domain. Okay, so that's what we're going to look at first, is a piecewise function. So we have an example. F of x equals, so it defines it a different way on different parts of the domain. So we're going to say x squared plus 2x if x is less than or equal to negative 1, and x if x is between negative 1 and 1, and negative 1 if x is greater than 1. So this is separating our domain. So if x is less than or equal to negative 1, we use this as our input. If x is between negative 1 and 1, then we use this as our input. And then if f is greater than 1, we use this. The thing that we want to be aware of is, see how this one goes up and includes negative 1, whereas this one doesn't include negative 1 but goes up and includes positive 1, and this one is going to be from greater than 1. So an example, f of negative 4. So we have to decide, where is negative 4 in these three pieces of the domain? So negative 4 we know is less than or equal to negative 1, so we know we're going to use x squared plus 2x. So we're going to put in negative 4 squared plus 2 times negative 4. So that would give me what? 16 plus a negative 8, which gives me a positive 8. All right, what would this one be? F of 0. So we go back up to our piecewise function and we try to find out where 0 is. So if f of 0 is between negative 1 and positive 1, then we know that it's going to be the same thing as x. So we know f of 0 is 0 because that was our x, right? F of x. All right, if I take f of 25 now. So I go up and decide where in these three pieces of the domain are we going to find 25. Well, we know 25 is greater than 1, so my answer is going to be negative 1. So we have piecewise function. Okay, so everybody has this down? Okay, the next thing we're going to look at is net change in the value of a function. So we're going to have net change is the value of a function as it changes from one input to another input. So we're going to have f of b minus f of a. So it's going to see what it does to change from one to the other. So if I have let f of x equal x squared plus 5x. Okay, that's my function. That's my action that I'm taking. So the question says find net change from -2 to +6. So we're going to find out what those things are plugged in first. So we're going to find f of -2, and we're going to find f of 6. And then we're going to take f of 6 minus f of -2. Okay, so this is my A, and this is my B, right? So this would be my f of A, and this would be my f of B. So net change is f of B minus f of A. So we have to calculate these values now. So if I plug in -2, I'm going to get -2 squared plus 5 times -2. That's plugging it into our function. This is our f of x. So again, put parentheses around that -2. So I get -2 squared is 4. And then 5 times a -2 gives me a -10, which gives me a -6. If I put in 6, I'm going to get 6 squared plus 5 times 6. So I end up with 36 plus 30. So 36 plus 30 gives me 66. So now I come down here, and the net change then is going to be my f of 6, which is 66, minus my -6. So 66 minus a negative. We know two negatives are going to make that be positive. So I end up with 72, and 72 is what we called our net change. So now let's try another one. So we're going to find the net change from 4 to 7. So we find f of 4, and we find f of 7. And how do we do that again? By plugging it back into our function. F of x equals x squared plus 5x. So I get 4 squared plus 5 times 4. So that's going to give me 16 plus 20 is 36. And f of 7 is going to give me 7 squared plus 5 times 7, which gives us 49 plus 35, which is 84. And then we have to subtract. So f of 7 minus f of 4 to get the net change then is going to give me what? 84 minus 36, which is 48. Okay, give everybody a chance to get up to this point first. Okay. So the next thing we're going to look at is evaluating a function, but this time we're going to have variables as our input. Okay, so we're looking at the function f of x equals 3 minus 5x plus 4x squared. It's kind of a funny looking 4. That's supposed to be a 4. So this time, evaluating the function, they want us to find first f of a. Now A is just our input. Just like we've been putting the other numbers in, we're going to put in an A. So I get 3 minus 5 times A, because X is A, plus 4A squared. So there is f of A. Lots simpler than you thought, right? The next one, though, is a little more difficult. The next one they want us to find is f of A plus H. So every variable, every x value, we're going to have as our input, but this time we're going to input A plus H. So we have 3 minus 5x, but our x is A plus H, so we're going to put A plus H in parentheses, plus 4 times x squared, but again, our input is A plus H, so we're going to have A plus H squared. So give everybody a chance to get that written down first. So now we've got to simplify this. So we're going to have equals, the 3 is just going to come down, but what does the 5 do? The 5 is outside the parentheses, so what's that called? Distributive properties. So we have to distribute the negative 5 into the A and the negative 5 into the H, so it gives me minus 5A minus 5H plus, now we have over here 4 and A plus H squared. Now I've encouraged you to make sure if you have something like this, then we write it as A plus H, A plus H. And the reason why we do that is that we don't forget the middle term, because a lot of times people will just square and write it down. But we have a middle term, so you have to make sure you do that. So we're going to come back again and we're going to write 3 minus 5A minus 5H plus. Now, I encourage you to do the FOIL first, A plus H, A plus H. So we're going to write 4 parentheses. So we have FOIL is first times each other. A times A is A squared. Outside ones is plus A times H. Inside ones is plus A times H. And last ones times each other is plus H squared. So this would be my FOIL. First, outside, inside, last. But now what do you see? You see that 4 is still outside this parentheses. So we have to distribute that 4. So we get 3 minus 5A minus 5H plus 4A squared. And then these two can be put together, but let's go ahead and keep them separate for now just so we don't get confused. So plus 4AH plus 4AH plus 4H squared. So now we've got all these things in a long row here, so now we're going to combine like terms. So is there anything that we can put together? You see the 4AH and the 4AH is going to give us 8AH. So we get f of A plus H equals, writing all these things down then, right? 3 minus 5A minus 5H plus 4A squared plus 8AH plus 4H squared. So this would be our answer for f of A plus H. Now the last one is kind of a tricky one, because we're looking at now combining these two answers, the f of A and the f of A plus H, into a what we call the difference quotient. So we're going to start out with the difference quotient is f of A plus H minus f of A over H. This is called the difference quotient. Now, why do we call it a difference quotient? Well, difference means subtract, so we have a subtraction, and quotient means to divide, so we have it divided by H. So now basically what we're going to do is we're going to take these two things, plug them in down here for the difference quotient. So A plus H is this long thing, right? So we're going to write it down. 3 minus 5A minus 5H plus 4A squared plus 8AH plus 4H squared. So that's all of this. Minus f of A. So minus 3 minus 5A plus 4A squared. So we're taking this f of A that we had up here and we're putting it down in here. And the whole thing is going to be over H. So this is not difficult, it's just kind of long and drawn out. So what do we have to do now? We have the minus sign. So we're going to distribute in the minus sign. So I get 3 minus 5A minus 5H plus 4A squared plus 8AH plus 4H squared minus 3. Negative times negative is going to give us plus 5A. Negative times positive gives me minus 4A squared all over H. But now what do you see that can cancel out? We've got a negative 3 and a negative 3 add to be 0. And you've got a positive 5A and a negative 5A add to be 0. And we have a negative 4A squared and a positive 4A squared that add to be 0. So give everybody a chance to catch up to that point. So now we're going to bring over what we have so we can finish it out. So we have negative 5H plus 8AH plus 4H squared all over H. So does everybody agree with that? So what do you see in common to that numerator that we can distribute out? We see an H. So we're going to take an H out. It's going to give us negative 5 plus 8A, because we took the H out, plus 4H. All over H. So now this is multiplied, right? So I can divide an H out of the numerator and the denominator. And my final answer then is negative 5 plus 8A plus 4H. I know, like I said, that seems like that's kind of long and drawn out, but you're following the steps as you go through. So everybody got it this part first? All right, so we're going to look at an example. A person's weight on Earth is 130 pounds. And the weight above Earth is given by W of H. So this is going to be the weight H miles above Earth. So we get a formula. W of H is 130, 3960, or 3960 plus H squared. Now, this stands for your weight at a given height. So weight is the W, H is the height. So this is not multiplication, this is the name of the function. W is the function notation, not multiplication. So the first question is going to say, what is the weight 100 miles above Earth? So what is weight 100 miles above Earth? So I'm going to have W100, that means the weight at 100 miles, right? So height was the miles above the Earth. So we're going to just plug in, and we get 130, 3,960, 3,960 plus H, but H is 100 squared. So now we use our calculators, and we find out that the weight at 100 miles above Earth is going to be 123.67, which would be approximately 124 pounds. So we can see this function. W is a function. It's acting on the 100, and we end up with 130 times this, and that gives us our weight. So functions can be in different forms. So we're going to look at a couple more examples of domain. So we talked about a minute ago, domain was the input. And we said domain is dependent upon the restrictions. Denominator cannot equal 0. And radicand has to be greater than or equal to 0. Remember, radicand is the thing that's under the radical. So an example, now again, these are restrictions. So we have an example for a domain. F of x equals 1 over x squared minus x. So in this one, we do have a fraction, so we do have a denominator. Here's our numerator and here's our denominator. So we have denominator cannot equal 0. So x squared minus x cannot be 0. So what we have to do first is factor this. So what do you see as a common factor? You see an x. So we take out an x and get x minus 1 cannot be 0. So if I have two things multiplied to be 0, then one or the other one has to be 0. So we have x cannot be 0, and x minus 1 cannot be 0. So adding 1 to both sides, I get x cannot be 1, and x cannot be 0. So how do I put that on a graph? I have a 0 and I have a 1. If it cannot be those things, what do I have to do? Well, I have to put an open circle on the number line to show that those are not part of the domain. So we have the rest of the number line is going to be our domain. So how do we write that? We write it in interval notation. Domain is, this way forever would be negative infinity to 0. Now since it's an open circle, we've got a parentheses. If it was a filled in dot, it would be a brackets. So we have union that with 0 to 1 from this part here between the two. Union that with 1 to infinity. So that would be our domain. So give everybody a chance to get that written down, and then we're going to try a radicand one. So again, this one is an example of find the domain. So we have g of x equals the square root of 9 minus x squared. So we said now this is our radicand. So radicand 9 minus x squared has to be what? Greater than or equal to 0. Now, we did some of these in Unit 1 where we had a quadratic inequalities. Quadratic because it's squared. So we're going to do that chart that we did before. We'll learn another method later, but for right now we're still practicing with the chart. So we have to factor first. So it gives me 3 and 3 plus x and minus x, right? And then the next thing we said we did was to set each of these to find out what the boundaries were going to be. So this one's going to be minus 3 to both sides, gives me x equals negative 3. This one I'm going to add the x to both sides, and that gives me x equals 3. So I go to my number line to find out my boundaries. So I've got negative 3 and 3. Since this is greater than or equal to, we're going to put in filled in dots. So now we're going to make the chart. Now I know some of you guys didn't like doing the chart in the exercises that we did for Unit 1, but let's try it just for a while. Then we'll learn another method later. So our chart is going to be 4 across and 5 down. So our boundaries are determined by our number line. So we have our name of our interval here. We have test points. Then our factors. And then our result. So our intervals are going to be up here from our number line, right? So we have negative infinity to negative 3, but since it's a filled in dot, we're going to have brackets. And then we have negative 3 to 3, brackets, because it's filled in dot, and brackets 3 to infinity. So our test points are anything in these brackets, in these intervals. So this first one, negative 4, between negative 3 and 3, I put 0, and then positive 4. So now we take the test points and plug them in. So 3 plus negative 4 is going to give me a negative 1. 3 minus a negative 4 gives me, minus a negative is plus, so that would give me a positive 7. Putting in 0 is going to give me 3 plus 0 is positive 3. 3 minus 0 gives me a positive 3. 3 plus 4 is 7, gives me a positive 7. 3 minus 4, remember again, I'm plugging into these things, these factors over here. So I get 3 minus 4 is negative. So our result says we're looking for where the product is greater than or equal to 0. So product means we multiply. Negative times positive is negative. Positive times positive is positive. Positive times negative is negative. So we're looking for where the product is greater than or equal to 0. So greater than or equal to 0 means positive. So my domain is going to be this interval up here, -3 to 3. Is everybody okay with that point? Okay, we're going to try one last example of domain. So I have f of x equals x plus 1 squared over the square root of 2x minus 1. And again, this is find the domain. So, do we have a radicand? Yes, we do. Do we have a denominator? Yes, we do. So we have 2x minus 1 is greater than or equal to 0 for the radicand part. But because it's in the denominator, this equals 0 has to go away. So we just have 2x minus 1 is greater than 0. Because if we had the equal to 0, then it would make the denominator equal to 0. So I add 1 to both sides. I get 2x is greater than 1. Divide 2. X is greater than 1/2. So how do I put that on a graph? I have 1/2. So greater than, we know is going to be an open circle, because greater than or less than are open circles, and greater than or equal to and less than or equal to are closed in circles or filled in dots. Greater than means our arrows to the right. So our domain is parentheses 1/2, because an open circle, comma, infinity, parentheses. So that's where we're going to stop with 2.1. Thank you. Bye.